Hey, it's me, Miss B, and in this video we are looking at the Unit 1 Lesson 20 cumulative practice problems. So let's dive in. For this first question, there's a little conversation going on here, I guess. So let's read through that, and then we're going to label this diagram based on their discussion, and then kind of answer some questions based off of that. So Priya says, I bet if the alternate interior angles are congruent, then the lines will have to be parallel. Han says, really? We know if both of the lines are parallel, then the alternate interior angles are congruent, but I didn't know that it works both ways. So what they're talking about is we have an if-then statement, like if, then, and they're talking about switching the order so that instead of saying like if X, then Y, they're talking about saying if Y, then X, because it doesn't always work the other way around. So this is what they're talking about. So Priya says, well, I think so. What if angle ABC and BCJ are both 40 degrees? If I draw a line perpendicular to line AI, so AI is this one right here, through point B, I get this triangle. So just talking about this triangle here in the diagram, angle CBX would be 50 degrees because 40 plus 50 equals 90. So based on our diagram and what she's saying, I see that so far. And because the angles of a triangle sum to 180 degrees, CXB is 90 degrees. It's also a right angle. So she's saying these have to add up to 90, which makes this a 50. And then because this whole triangle has to add up to 180, that means this has to be a 90-degree angle. So far, checks out. So Han says, oh, then line AI and GJ are both perpendicular to the same line, which is this one, BX. So lines AI and GJ must be parallel. So we're going to label some things here based on their discussion, and then I'll probably highlight some stuff too. So the first thing that they said was this is 50 degrees, and this is going to be 90 degrees. So that's at least just the angle measures they were talking about. So I'm going to highlight them though. That way it's a little easier to see like, hey, this is what I was doing, is this stuff here. And then they're asking us, is there something special about 40 degrees? Will any two lines cut by a transversal with congruent alternate interior angles be parallel? So the answer is, to the first one, is there something special? No, there is not something special about 40 degrees. And the second question is, will any two lines cut by a transversal with congruent alternate interior angles be parallel? And the answer to that is yes. So we're just going to say, see over here, see diagram. So we're going to say no, 40 degrees is not special. And then we can basically say the whole argument that Priya went through here in her paragraph, we could do that with a variable. And instead of 40, we could use like an X or a Y or something like that. And it would prove for pretty much every case. This can be done with a beautiful. Instead of 40 degrees, and that would prove it for any angle. So instead of saying 40 and 50, we would end up saying that, like, just as an example, I'm not going to walk through the whole thing, but say if we instead said that 40 was x, instead of 50 then being here, we would know this would have to be 90 minus x. And so we would end up with x and 90 minus x. We would also end up with this 40 being x. And we would still know that these would add up to 180. This would still have to come out to be 90. So those same arguments would work. Okay, let's look at question number 2. So for question number 2, we're looking at the same sort of diagram again, but with a couple different things here. We are going to be asked to prove that these are parallel. So I like to organize proofs as 2 columns. And I know that's not the way they're kind of doing it here. They're just asking us to, in general, sort of explain our way through it. So, okay. I'm gonna look at and notate on the diagram first before I write everything out. I always look at the diagram first. I kind of think of it like my roadmap. If I am trying to figure out how to get from one point to another, I'm gonna look at the map first instead of just writing my turn-by-turn instructions just off the cuff. So I do the same thing with proofs. I like to annotate on my diagram, so that way I know. So the first thing I'm seeing here is I have a couple angles here. A, so let's actually maybe we'll make this blue. Angle A here is blue. I also have this angle is A degrees. So we're given those two. Now, what else do we know? I know a couple different things here. So first off, I know that this is also going to be A degrees because this is a vertical angle with the other A degrees. I also know that this down here could be A degrees as well, for the same reason. It is a number of degrees, because it's a vertical angle with A degrees. Okay, so we're kind of going to go through Priya's explanation here, which means we're not going to need this A down here at the bottom. But the one that Priya walked through in the question above basically says if we have those things there, and we have A degrees here, we can then say that this angle on the inside is going to be 90 minus A. Oh, hey, look, we're doing this as a proof in the very next question. So, because it's complementary, so that's why it's a complementary angle. We know that it needs to make 90 degrees somehow. And then this entire triangle, through the triangle sum theorem, triangle angle sum theorem, basically the triangle will have to add up to 180 degrees. That's our triangle sum theorem. Triangle angle sum theorem. It is all of those words. So we then know this is going to be 90 degrees by our triangle angle sum theorem because we're going to have A plus 90 minus A plus something equal to 180. So it has to be 90 degrees. And since now we have two lines perpendicular to the same line, they are going to be parallel to each other. So let's write that out in an explanation here. Okay, so I'm going to start with the one angle that I labeled there A, and say angle, measure of angle A, B, C equals A degrees, because it is, okay, let's see how much room I have here. So it is a vertical angle with angle EBI, which is A degrees. We can say the measure of angle CBX, so this one right here, the 90 minus A, because it is complementary with angle ABC. Complementary just means the two of them need to add up to 90 degrees. Since we may not have formally defined that. Now we're going to say the measure of angle CXB, and that is that corner down there. So CXB, we'll make this one maybe yellow, I guess. Talk about the yellow corner. So we say this one is 90 degrees because triangle, so because triangle the triangle angle sum theorem. Oh, but it's triangle CBX. CBX must add up to 180. And this is the triangle angle sum theorem. Okay, so once we've established these things, I'm essentially writing a two-column proof here saying statements and then because statement and then because. That's what a two-column proof really is. It's giving a statement and then saying your reason for it. So we have 1, 2, 3 steps here. Let's say we have bx. Now because of that, bx is going to be perpendicular to AI, and bx is perpendicular to gj by definition. We can say therefore AI is parallel to gj. Okay, so a bit involved, but at least clearly labeled. And hopefully that made a little bit of sense. I'm sorry I had a little bit of pause there. little brain fart trying to remember what I was trying to think of for the name of triangle CBX, because I knew the triangle angle sum theorem. So, okay, let's move on to question 3. So question 3, we have now here a straightforward question, not a proof. Proofs can be exhausting. What is the measure of angle ABE and how do you know? Well, this is going to be 50 degrees. 50 degrees because of vertical angles. So we can say because vertical angles are congruent. Okay. Question 4. Lines AB and BC are perpendicular. The dashed rays bisect angles ABD and CBD. Explain why the measure of EBF is 45 degrees. Okay. So we're going to kind of label some of these things here, but I'm going to highlight our dashed lines just because I think that makes things a little easier to see. So I have our dashed line here, we have a dashed line here, which means we want to know this angle altogether. So these are the dashed rays. We know that they bisect angles ABD and CBD. So ABD, that's this angle here. CBD is the other angle on the other side. All right. I do want to label some things here. So since I know that these are bisected, I know they're going to be equal, but I don't know necessarily what their angle measures are. So we can use some variables here. We can use X, we can use Y, we can use A, we can use B. I'm going to use, let's use A and B. So I'm going to say, let's say this is A degrees. That means this is also A degrees. And then if this is B degrees, this would also be B degrees. Instead of just like cutting it in half or saying it's A and saying it's B and then using half of A and half of B. So we know that since 2A plus 2B equals 90 degrees, dividing by 2 means that A plus B is equal to 45 degrees. Oops. So A plus B is equal to 45 degrees. We can say therefore angle EBF is equal to A plus B, which is equal to 45 degrees. Okay. Now we're skipping over question 5 and we are going to go right to problem number 6. So if you were looking for question 5, we're skipping the traditional question 5 here and just doing number 6. So we have quadrilateral A, B, C, D, and it is congruent to quadrilateral A prime, B prime, C prime, and D prime. We want to describe a sequence of rigid motions That takes A to A prime, B to B prime, C to C prime, and D to D prime. So one of the things I like to do first with these is really just determine, do I need to do a reflection of some sort? And you can tell that by checking what order your letters go in. So I like to start from the first letter and then follow around A, B, C, D. This looks like we are going clockwise. I'm sorry, counterclockwise. So if this one is counterclockwise, we can check this one as well. A prime, B prime, C prime, D prime. Looks like, again, we are going counterclockwise. So we don't actually need to reflect because they would be going in different orders or different directions to go in that same order. So this just means we're going to have a translation and then a rotation. So first, let us translate. I'm going to say translate A, B, C, D. So that, you know what, let's use, I like B's kind of close together here on my graph. So I'm going to say so that B coincides with B prime. So now that I've chosen B to be the point that's aligned, I have to use that as my center of rotation. So now we would say rotate the image. Around B prime until we can say any of the other points, so just A or C or D. We'll just say A until A coincides with A prime. And yeah, that is our full transformation. Continuing on. So on to question 7 here. We want to identify, oops, no, sorry, not identify. That's the next one. I started reading from question 8 down here, identify. For question 7, we are looking at this triangle. So it is congruent, or they are congruent. We want to describe a sequence of rigid motions. So first things first, I'm going to check. Do they go in the same direction? A, B, C. This one looks like we're going clockwise. A prime, B prime, C prime, going the same direction clockwise. So just going to be the same sort of thing as the previous question. We're going to translate and then rotate. Same idea. We could actually use the exact same description as our previous one because we just used A and B. So we can do that here. And it's not cheating, it's recognizing that it works for both of these situations. So we're going to translate. The only thing that's going to be different is we're not going to say A, B, C, D. We're going to say A, B, C because it is a triangle and not a quadrilateral. So we're going to say translate A, B, C so that B coincides with B prime. Rotate the image. Around B prime until A coincides with A prime. That's it. Not too bad. Okay, for number 8, we are going to identify any angles of rotation that create symmetry. So angles of rotation, those are based around basically how many of these pieces you have repeating. So I see that I have 3 of the same element here, which means I am going to most likely be taking 360 degrees and dividing it by 3 or into 3 pieces. So I am going to do that. Yeah, let's put a dot in the middle here, and then we can kind of draw some lines here that would work as our sort of our center of rotation area. We're drawing our lines so they're kind of neatly in between each of our petals, but the whole thing is 360, so this distance here, this is 360 divided by 3. So that is 120 degrees. And we know any multiple of that will work. So that means 120, 240, and of course everything goes 360. So we're just gonna consider these to be our angles of rotation. Okay, number 9 is kind of similar, but they're giving us some options. We're gonna try to find the smallest amount that would create symmetry for this flower, and then look at our multiples of that. So how many pieces do we have? It looks like we have 1, 2, 3, 4 on the top and 4 on the bottom. So our smallest unit of rotation is actually going to be 360 divided by 8. And if we divide it by 8, that's actually going to give us 45, which, nicely enough, if you kind of look at the 90 degrees here, you'll see there are 2 within there. So yes, one should be a 45-degree angle. So knowing that that is my smallest increment of rotation, I'm gonna just kind of draw in my lines here in between so you can see more exactly what I'm talking about. So each of these is 45 degrees. Yeah, so now we're just going to select everything that is a multiple of 45. So all the way up through 360. So 45 works, 60 does not, 90 does, 120 will not, 135 will, 150 will not, and 180 will. So we have 45, we also have 90, which is here. I'm going to actually erase a little bit of this just so I can write in a little bit better. So 45, then we're going to have 90, and then 135 is all the way here, and 180 is from here all the way around to here. So those are our 4 angles that we've shown for rotational symmetry. Obviously there are more, but we're just selecting all of the ones that they give us. So last question here is, the line segments form the letter N, rotate it clockwise around the midpoint of segment BC by 180 degrees and describe the result. So if I try to put a midpoint here on BC, it's going to look a bit like this. You know what? Let's draw our shape here just for you to see. I can't rotate my tablet, but I can rotate some shapes that I draw on it. We'll put some points. I will label them afterwards. If I put the letters in there, it's just going to mess up a little bit where my center of rotation is, but I guess I can do that now. So let's label this A, B, C, and D. And then if I took this whole thing, I can rotate it 180 degrees, and it's a little smaller because I can't sometimes control how much I resize things, especially if it's a little off center because of the letters like this. So that would be my result, 180 degrees. I just kind of have everything flip-flopped in order, but I still have an N. So this is going to be A prime, B prime, C prime, and D prime. So it is another N. Because it did ask me to describe the result, so I'm just going to say it's another N. It's the same letter N, but we have the letters in different places. And that is it for us for assignment number 20. So a little bit long here with some of the proof stuff, so sorry about that, but thank you for sticking with me. And this has been Unit 1, Lesson 20, Cumulative Practice Problems for Illustrative Math Geometry.